So last time we talked about simple interest. Now let's talk about compounded interest and how we can get a formula for it. Yes, that is a money tree. I found it. So let's go into something before. Remember how to switch things from decimal to percentage and from percentage to decimal? Now I'll show it to you, but 80% is 0.80, not 0.08 or anything like this. 100% is really 1. 8% is 0.08. And here's an interesting one, 1.45%. Sometimes students have a hard time, but this is 1%. We know that's 0.01. And then there's more stuff, 45. So it's 0.0145. The first two are going to be like this is 1%, this is 8%, that's 8 and 0, so that's 80%. So if we go the other way around, 0.15 in decimal, well, that's 15%. 0.7, well, that's 70%, not 7%. 0.07, that's not James Bond, that's actually 7%. 0.002, okay, that's not even 1%, so it's 0.2%. And 3 is actually 300%. Hopefully that makes a lot of sense. And the part of that it makes things easier for us is when you say, okay, there's an increase of 13%, it's 100% plus 13%. I really have like 113%, which means it's 1.13. If it's a discount of 9%, well, I started 100%, and I dropped 9%, well, I got 91%, and that's 0.91. And if I have 1.5% increase, well, that's 1.015 in decimal. Good. So this is useful because when we have something like this, if we need to pay for something, buying a shirt, a money shirt, and it's 1580 with 13% tax, okay, if I want to add 13% tax, the old way was like, okay, I figure out what 13% is, then I add it to 15, but we can do it in one shot. We can say, well, 100% of the price plus 13%, I'm really going to pay 113%, which is just 1.13. So here's the old way, which is calculate just the tax, and then we add it together. But it's much easier if we just do it in one shot. We say 1.13, and then 1785, we get the exact same answer. So that's good. And the same way, we can do this example where a car is depreciating by 15%. Okay, well, it's depreciating by 15%. I'm only going to have left 85%. So calculate 85%, and you do that in one shot. Good. Okay, let's move on. Let's say we have invested $2,000, so 6% compounded annually for 4 years. How much will you have in the end? And that means that was like the table that we did last class, that you're going to figure one out. You bring it back to the bottom. So you say 0.06, you get 1.06 because it's 6% more, right? So 1.06. So 2,120. Then you say, okay, 2,120 multiply 1.06, and I get this number. I bring this number down, 1.06, and I get this number down. And I bring this number down, 1.06, and then we end up with 2,524.95. Now that's fine and then if it's 4 years, but what if it was compounded monthly? Okay, crap. That means we're gonna have to do this calculation 12 times per year, 4 times. That's 48 calculations. That's a pain in the butt. So, but you may notice that we're doing something repeated over and over. All I'm doing is I'm multiplying my 1.06 by 1.06 by 1.06, my answer. So really just I'm multiplying 1.06 4 times. And that's to the power of 4, not times 4, to the power of 4. So here's where the formula comes from. So the formula for compounded interest is A is equal to P, bracket, 1 plus I to the power of N. What do those numbers represent, or letters represent, sorry. So A is the final amount. That's the A for the amount. But it's really, I'm going to call it the future value. It's how much money you're going to have in the end. P is for principal, but I'm going to call it the present value because how much money you have at the beginning. Now this present and future business is not really time-wise. It's like at the beginning, we're going to call it present, and at the end, we're going to call it future. Like this could be something that you invested money 10 years ago. How much did you have 5 years ago? So they're both in the past, but still the beginning, we're going to call it present value, and the end, we're going to call it future value. Then I, it's 1 plus I. So the I is the interest rate per compounded period. That's really important because if I'm compounding per year, I want to get the interest rate per year. If I'm compounded monthly, I want to get the interest rate per month. Okay, so that's going to be that's the only thing that we're going to struggle with or have to be careful with. And N actually is the number of compounding periods. So that depends. if it's in the previous example, n was 4 because it was 4 years and it was compounded annually. But if it was 4 years and it's compounded monthly, we're gonna have 48 because we do the calculation 48 times. So number of compounding periods. And I'm gonna show you a silly question to be able to get this. All right, I'm gonna let you just to copy this down. I won't talk through it. If you wanna stop it and copy this table, there's 1 annual period, 2 semi-annual periods, 4 quarterly periods, 6 bi-monthly periods, 12 monthly periods, 26 bi-weekly periods, 52 weeks, and daily is 365. Sometimes it's 366, but we're gonna stay with 365. The one that's interesting is quarterly, and you gotta pay attention to quarterly because quarterly, there's 4 quarters in a year, but there's actually 3 months in every quarter. And that sometimes gets a little confusing because if I'm talking in months, I need to get groups of 3 months. But if I'm talking in quarters, there's 4 quarters per year. Hopefully that made sense. A little scientific notation, you can look that on your own. And here's a big point. Never round interest rate. Never round interest rate. Let the calculator take all the decimals because it makes a big difference, particularly when we're investing or do calculations for a long time. So just a little change ends up being a big change. So we never round interest rate. We're gonna leave it as a fraction, very likely. All right, so here's the silly question I talked about before. How do you determine n, the number of periods? Just ask yourself this. How many compounded periods are there in total time? So for example, how many months are there in 4 years? Also, it's, oh, there's 48 months in 4 years. Okay, n is 48. If you say, sometimes it's silly because you say, okay, how many years are there in 4 years? Well, that's 4, just like in the previous example. So sometimes it's pretty silly, but sometimes it will get you out of trouble. Many times it will get you out of trouble. So let's try this. All right, if it's 3 years and it's compounded bi-weekly, how do you figure this out? Well, you ask, how many bi-weekly periods are there in 3 years? Bi-weekly, that was 26, and there's 3 of them. Oh, so it's 26 times 3, that's 78 periods. So n is 78. If you say 2 years and monthly, well, how many months in 2 years? Well, 24 months, so that's pretty easy. Quarterly in 42 months. Okay, that's tricky because quarterly periods, there's 4 per year, but they gave me the time in months. So how many months in every quarter? There's 3, right? 3 months in a quarter because 12 divided by 4 is 3, it's 3 months. So I want to get groups of 3 months. So I got to do 42 divided by 3, and that gives me 14 quarterly periods. I know that was tricky, think it through. How many semi-annual periods are there in a year and a half? Well, in 1 year there's 2, and half a year there's only 1, so there's 3 of them. Good. Okay, so here's the real question now. So if you have deposited $400 at 4% compounded monthly, how much will you have in 2 years? Okay, so in 2 years, let's figure out the I. The I is 4% slash A. Remember, slash A was per year. So 4% is 0.04, but it's compounded monthly. So if it's 4% in 1 full year, in just 1 month, I need to divide it by 12, right? So basically the I is going to be 0.04 divided by 12. Now if you plug that into your calculator, you're going to find out that that number goes on and on. So just leave it like that. We're going to actually use the fractions for I, and then it's easier for us on the calculator and it's more accurate. So win-win. And then to figure out the n, we say, okay, how many months are there in 2 years? And probably in our head, we're just going to say 24. And then we plug it into the equation. 400 bracket 1 plus 0.04 divided by 12, close bracket, to the power of 24. Notice that some of you really like using the fraction button. I don't know why I really don't like it. I'm just going to say 0.04 divided by 12 when I go into the calculator, and we get our answer. So the answer is 433.26, which really means that we made about $33 and a little bit on interest in this time. Good. Another question. This is not financial, but it kind of makes sense. How many people will be left in a small town of 5,000 people after 4 years if the population is decreasing by 8% per year? Okay, it's decreasing, so that's why I put a negative 0.08. I don't need to divide it by anything because that's like per year. So we're talking years and per year, so this matches nicely. And N, I'll ask the silly question. How many years are there in 4 years? Oh yeah, that's silly, it was just 4. So plug it into our equation, 1 minus 0.08 to the power of 4. 3581. Of course, we're not gonna do decimals because we're talking about people. Okay, one last one. And let's say we have, how much will you have after 50 years? So if you put some money down now, if you deposit just 250 bucks and you get a daily interest rate, an annual interest rate of 4.1%, but it's compounded daily. So every day they're gonna pay you a little bit of interest. Okay, so we gotta figure out the I first. The I is, this is 4.1 is 0.041, right? But that's for a full year. If that's the full year, a day is like really, really small. So we need to divide it by 365 to know how much they're gonna pay us one by one. So that would be 0.041 divided by 365 because there's 365 in 1 days in 1 year. And what's the N? Well, we're gonna say how many, the silly question is like how many days are there in 50 years? I have no idea, but I know that 365 days is in 1 year. So if I want 50 years, I'm just gonna multiply it. And that's gonna be 18,250. And that's it. Now just go into the calculator, plug it in the formula, and it's 250, which is the money I put down, 1 plus 0.041 divided by 365, close bracket, to the power of 18250, and let's see what the answer is, 1,941.75, which doesn't seem like a lot, right? But hey, just think about how many more times of the money that you put down you got after 4 years. Good stuff. This is the future value for compounding formula.